Hey folks, welcome back. We are finishing up our review of the getting ready for exam 3, and here we have what I'm calling Oops, I Broke a Spring. So we have a hanging plate. Here it's a square plate. The spring 2 just broke, and we are asked to find the accelerations at point A and point B. So let's get to it. I'm going to go ahead and draw a free body diagram here because there's some things missing from that schematic. I mean, I did a good job on it. I know that, but I didn't put the weight in. Right, so here's the weight. This is point G, and this is T2. It goes away, but we need to know some things before we send it away. So T1, T2, perfect. Also, back to this idea of needing I-bar. So we're going to need I-bar, and I-bar G is fine here. I-bar G is 1/12. M times the, it's base squared plus height squared. And since they're both B in this case, let's make this B. So it's 2B squared, so it's, wait, that's not 1/2, that's 1/12. Right, so it's MB squared over 6. Okay, and what we can do here is we can start just by analyzing this before things broke. So if the sum of the forces in the y direction before it broke, it was 0, right? So T1 plus T2 equals W. Sure, that's pretty straightforward. And if we take a sum of the moments, say about, we can do this about point A, this is B, right? Then we'll do, actually let's come down here. Let's draw a line there. Say the sum of the moments about A, again, it's before everything broke, then that's 0. And, let's see, let's call this positive. So, B times T, T2, minus B over 2 times W equals 0. The B's cancel, right? So that means that T2 is equal to W over 2, right? Similarly, then that would also have to equal T1, right? That's straightforward. All right, well, now as we're moving forward, then we're going to analyze as right after things broke, right? And so there we want to analyze at the center, right? What we want to do is we want to take a moment about the center. And when we do that, then remember, we would need the parallel axis theorem, except that the point of rotation is assumed to be the center. So we say the sum of the moments about G is equal to the sum of the moments effective about G, And what contributes to that? Well, the weight goes right through point G, so we have T1, and that is times B over 2. That's how far away it is, right? And that's going to be equal to I bar G times alpha, right? And we know that I bar G is MB over 2, right? So we have T1 is W over 2, so W is mg, so mg over 2 times B over 2 is equal to, well, I guess we can just divide this across, right? And this becomes times 6 over mb squared, right? So we just multiply times the inverse is equal to alpha, right? The masses cancel. The b's, this b cancels. That's a squared, so that's still there. And 2 times 2 is 4, so it's 3 halves. So what is this? This is equal to 3g over 2b. Okay, well that's good to know. We're going to need that. And so now that we have alpha, we can just do a sum of the forces in the y direction, and that will give us our AY, which we will then use. We'll use our alpha and our AY, so our acceleration in the y direction of the whole thing. We'll use that to get our accelerations for A and B, right? So the sum of the forces in the y is equal to the sum of the forces in the y effective. Okay, and so what do we have? We have W up is positive, so T1 is W over 2. Okay, and that's going to be minus W, and that's going to be equal to, well, mass times acceleration, right? So m_a_y, and this is, what is this? This is minus 1/2 W, but these are mg's, right? So let's move this over here, and that's going to be minus mg over 2, right? And there, so AY is equal to minus g over 2. All right. Okay. So it's an awful lot of buildup, isn't it, to get to the finale? All right. Well, now we can really just, since we have AY, we know the acceleration of the center, and we know the angular acceleration of the center. So if you haven't already done it, now's a good time to pause the video and see if you can figure out how we're going to get to the end. Right? And I probably should have noted that at the beginning, right? Giving you that opportunity, but I'll put it in the assignment. So, at any rate, let's see. Okay, so hopefully you paused the video and you figured it out. So what we can do is we can use the relative acceleration, right? So A sub A is equal to A sub G plus A sub A with respect to G, right? So the translational plus the rotational. So let's see, this is equal to A sub Y, right, plus, and what is that? That is going to be the normal and tangential components, right? So, what do we got here? I gotta think for a second. That is it's just the, I'm sorry, it's not the normal and tangential, it's just the rotational component, since we're relative to the center. So, because A isn't moving up and down. So what do we got? We got R cross alpha, right? So let's see. That's going to be from G to A is minus, so minus B over 2. And that's going to be crossed with alpha, right? So let's put that. So what does that equal? That equals minus G over 2 minus B over 2. And alpha is right here times 3G over 2B. And let's see, the B's cancel there, and that's 3/4. So minus G minus 1/2 minus 3/4. Let's see. Minus 1/2 minus 3/4. So this is 2, 4. So it is minus 5/4. Minus 5/4 G, and that is A sub A. Alright. Do I have that? I feel like I have that wrong. Which direction is this rotating? Oh, right. That should have caught my attention. So this is rotating this way, right? So that means that alpha is negative, when which is good, because this should be 1/4 G. There we go. And yeah, negative times a negative. Okay, now A sub B, same thing. A sub Y plus A sub B over G. Right, and notice that this is actually A sub G. So we have minus G over 2, and then now plus sub B over 2, and then alpha is the same, it's minus 3G over 2B. These cancel, it's 3/4, and minus minus, so A sub B is equal to minus 5/4 times G. So the again, and I really can't stress this enough, as you're working through these problems, these early kinetics problems, and getting used to what they're wanting you to do, try to just map out your solution strategy. In this particular case, there was several calculations before things broke so that we could go after the variables we needed to get the alpha and the a, right? With those, then the relative acceleration is simple, right? Because the g, being the center, bypasses the parallel axis theorem, makes the calculations a whole lot easier. And also note that because this is a spring, the acceleration is not going to be zero, right? The load just shifted. So it's easy, like if this was just a chord, then the acceleration might be 0 in the y direction, but definitely not in this case. So at any rate, I hope that was helpful. I hope that the video helps you to crush the exam, and I will see you in the next one.